to start the session in couple of minutes. So I request everyone to join in fast. So in next 5 minutes, we'll be starting the session, guys. So I request everyone to join in fast. So good afternoon, everyone. So I request all my dear professors, colleagues, members to join fast. Still, we have reached only 150. So I'm going to start the session in next 2 minutes. So I request everyone to join in fast so we can start the session earliest. So guys, in next 2 minutes, we're going to start the session. I repeat, I request everyone to join in fast. So I request, it's a humble request, everyone to join in fast so we can start the session. So today we're going to start with a new topic after covering the code walkthrough for the NN. So I request everyone not to miss this from the beginning. Today's topic will be, we're going to start with the convolution neural network. So something related to computer vision, guys. So very super exciting topic for the day. And before that, we'll try to cover the code walkthrough. We'll try to set up the ANN. I hope everyone is excited as well today as well. So I request everyone, we just reached 160, guys. I will wait for 2 more minutes. I don't want anyone to miss the session. It's very important today to start. So request everyone to join in fast, guys. Please inform your friends, colleagues to join in fast so we can start the session. Meanwhile, guys, if you have any questions, any doubt, please let me know in the chat box so you can start interacting with me. So please let me know any questions, any doubts you guys are having, so we can start answering them immediately. All right, guys. So in 1 minute, I'm going to start the session. Today, still people are not joined in, so I request everyone to join in fast so we can start the session at earliest. We have just reached 180. We are supposed to cross like 500. So I request everyone to join in fast. Please inform your team member, colleagues, your professors. Please join in fast. And meanwhile, guys, people are joining in. If anyone having any doubts, any questions, please let me know. You can start interacting with me in the chat box. So I'll try to take some couple of questions if possible. Right. So okay, guys. So we can start now. I think most of us are still joining in, but let them join as per their convenience, and we can start for the day, guys. So all right. I think everyone is able to see my screen already. So from the participant side, guys, can you please just quickly confirm? Please confirm me in the chat box so you are able to hear me properly. You can see my presentation, so we can start for the day. Anyone from the participants, please confirm. Yeah, okay, Pranita, thank you. Pranita, sir, ma'am, thank you. Thanks for the confirmation. Yeah, Abhay, sir, thank you. All right, sir. So we can go ahead now. So today we already discussed around the entire artificial neural network as how the entire ANN works upon, right? What is the architecture? What is this artificial neural network is all about actually? And we were able to understand something related to the forward propagation, something related to the backward propagation, and what kind of operations are happening. What do you mean by exactly ANN? And in the backward propagation, we were able to understand that in backward propagation, the actual neural network, okay, in backward propagation. So just forgive me for my handwriting, guys. So just in the backward propagation, we were able to understand what kind of a derivatives are taken, what kind of optimizers are used, how it is able to understand the weights and biases, and how this entire artificial neural network is able to cover the entire this model optimization parameters, right? So this is what we started, guys, and then we were able to understand the entire process, that how this entire things works upon right from the beginning, that a three-layer architecture from Pitts. Then in 1943, they introduced the single neuron model. Then they brought up the entire perceptron model. And by using the perceptron model, we were able to understand something called as input layer, hidden layer, and the output layer architecture exists. And out of this architecture, we will be able to receive our final prediction. And this entire process, when I'm just forwarding my inputs here, it is getting multiplied by the weights x1 into x2 multiplied by weight 2, x3 multiplied by weight 3, and x4 multiplied by weight 4, and then so on. And then here we will have something called as summation of x into w, and this summation will pass through something called as my activation function, and this activation function will be able to accept this summation into the multiplication of individual words, which I call is xi wi. And once I am able to perform this kind of operation, I will be able to get some output, and this output is coming out here, and that output will get also multiply O1. Output 1 will also get multiplied by one more weight, that is weight W5, and then that will be that call that as a Z1. So this Z1 will again pass through one more activation function, and in the end, guys, we'll be able to get our Y hat. And when we understood this entire operation, what is going on, so we were able to understand what kind of optimizers are there, what kind of activation. This is what the operation happened, two-step operation. And then we were able to understand what is the activation function, what the role it is playing, how it is able to convert the entire thing, whether it will be able to activate or deactivate, and what kind of a transformation is able to perform using this kind of a entire kind of a different formulas and different activation function. We were able to divide our data or transform our data using this kind of activation function in the form of 0 to 1 or -1 to 1 or 0 to infinity. So this is what we were able to understand, and then we were able to understand that how the entire loss getting calculated, what are the different laws, what is the categorical loss, all right. And then once we are able to understand this thing, and we were able to look at the optimizer, which is actually helping us to find out the optimal value of weights and biases, and through which the entire algorithms learns, right? And not only this algorithm, ANN, but entire all the machine learning algorithm, AI algorithm learns by this kind of optimizers. And this is what the backward propagation we were able to understand. And then we were able to understand that what kind of a derivatives are taken and how the derivative calculation happens, guys, right? And then certainly we wanted to discuss, since we have discussed what are my some kind of a disadvantage which happens during this entire calculation process, which is called as vanishing gradient problem, exploding gradient problem. In vanishing gradient problem, my entire weights gets very small, so that my learning gets actually small, or which is very close to the zero, which is derivative of loss with respect to weights. After n number of times when I try to take the derivative, it will remain close to zero, and because of which my new weight is actually becoming as same as the old weight, and where my entire ANN stops learning. And this is what the problem was, the vanishing gradient. And in exploding gradient, again the problem was very different, where I started at this point of time, and what was happening is it is exactly opposite case. At after n number of times when I'm trying to take the derivative of this loss with respect to my this function of weights, sorry, so less loss with respect to weights, and what is happening is my old weight is very large as compared to the new weight, right? There is a huge difference, and because of this difference, this my algorithm is not able to reach to this 0 point, right? Global minima point, something called as my global minima, right? Global minima. We were able to understand graphically also how my cost is getting reduced towards the 0 point, and for that cost, what is my weight and what is my biases, and that entire information of weights and biases has to be taken, which will be able to give me a cost or loss which is equal to zero. And what was happening in the exploding gradient descent, guys? It was giving me very large weights, right? And because of which I am not able to learn the thing, or I was able to move like this way. A high jumps were taken, and in this way I was missing my global minima, and that was the problem exactly I was facing. All right. So this is what the discussion we did, and we were able to understand, guys. So if I am facing overfitting, if I am facing vanishing gradient problem, if I am facing exploding gradient problem, there is a one technique, one regularization technique which come into the picture, which will help us to solve this problem. So before I start, guys, can anyone quickly tell me, so what is the regularization technique we have discussed yesterday, which is layer it is called as, and what it is exactly doing? Can anyone briefly tell me what kind of a regularization technique we have learned yesterday, which was able to give us a benefit that we will be able to get away with this kind of a vanishing gradient problem, exploding gradient problem, and the regular overfitting. Awesome, Sanam, ma'am, sir. Thanks for this one. Dropout layer, this is what we are able to understand. Dropout layer, right? So the dropout layer comes to our help, and this will aid us to find out or to get eradicated with this kind of a thing, right? Pushpa, sir, thank you. Hey, Pushpa, thank you, sir, ma'am. So thanks for this entire engagement and this kind of a prompt answer. Really appreciated. All right, guys. So we were able to understand what is the dropout layer and how by using the dropout percentage between 0 to 1, right? So we were able to take the dropout percentage, and whatever dropout I will be taking, accordingly, I will try to deactivate. I'll try to deactivate some of the neurons, and by deactivating some of the neurons like this one, so I will be able to perform something called as regression technique, and by use I am going to penalize my entire artificial neural network. This is what we have learned until now, right? Okay. And then, guys, the last concept which I wanted to discuss with you, that whenever this kind of a entire derivatives are happening, so that derivative is not that simple actually. So let's go back to the earlier side first. And here I will try to explain you one kind of a thing which is called as chain rule actually. Chain rule is very important concept. And in short, if I want to tell you, like when I am trying to perform a backward propagation, like this back propagation, at that time, what is my main aim? My main aim in the backward propagation is to perform something called as weight updation, right? Something called as weight updation. And I am trying to reduce my loss function, which is not exactly equal to be 0. So my main aim is to make it close to 0. This is what my main aim is, to reduce this loss, optimize this loss using the optimizer, and to find out the optimal value of my weights and biases. And in order to find out my optimal value of weights and biases, what I'm trying to do, I'm using this formula. Weight new equal to weight old minus something called as my learning rate eta into derivative of loss divided by derivative of weight, right? This is what I am trying to perform. This is my formula for the weight updation. Now guys, let's try to take the example. Let's try to understand what do you mean by chain rule. Chain rule, if I try to summarize the thing into the one-liner concept, it will be called as whatever weights we are trying to update. Like we are started with the loss function out here, and our job is to, once I start with the loss function, my entire aim is to go back, right? Go back with respect to the time, go back with respect to the time, with respect to time, and then try to understand why I am able to get this kind of a loss, right? This is what the investigation process I am trying to perform. And let's imagine I started my journey from the loss, guys. So this loss I have started, obviously, if I am going back, the first thing which I will encounter is my y hat. And from y hat, I will encounter something called as my O31, this output. And from this output, I'll go back here. So I will receive something called as O21. And from O21, guys, from O31 only, I have a two path to take. One I can go to O21, or second I can go to O22. Both the paths are available. Let's imagine I chose to go by O21, and from O21 I will be able to update this weight. I will go and visit this weight. I will go into the hidden layers here. So this is hidden layer 1, and this is my hidden layer 2. And from hidden layer 2, I will try to update something called as my O11. And from O11, I'll try to go back to W11. And from W11, I'll try to reach to my respective inputs, right? So this kind of my input layer. So this is the entire backward journey which I'll be performing. And then, so what do you mean by chain rule, or what exactly the chain rule talks about is when I am trying to subsequently update the weights. When I'm going back, this journey of going back and updating the weight, it depends on my subsequent weights. What do you mean by subsequent weights? Means let's try to take the example of W11. So if I'm trying to update my weight W11, W11 will be depend on this one. W11 will be depend on this O21, and O21 depend on this O31. So this is what the entire chain is getting formed. So when I starting from the loss, guys, from loss I am coming to y hat. From y hat I am going to O211. From O211 I am going O11, and from O1 I am going to W11, and then only I will be able to update. So this is forming some kind of a chain, guys. Some kind of a chain means that many derivatives I have to perform in order to update this kind of a things. So usually if I try to write something called as, if I want to update W11, right? This formula, let me rub these things, and let me tell you, this is my weight updation formula, correct? Old weight equal to, new weight equal to old weight minus learning rate eta, and then multiplication of this derivative with respect to loss. Derivative of loss with respect to weight. So let's imagine I want to update this weight, right? So if I try to go as per this formula, so what I'm going to write, derivative of loss with respect to this W11, right? W11. So if I want to write W11, or let's take this example here, this weight will come first, okay? So rather than going here, first I'll try to start updating this weight, W11, right? This is my immediate weight. So I'm writing derivative of loss with respect to W11, this layer number 3, okay? This is layer number 3 actually. So this 3 layer W11 I am updating, okay? This is what I have written. So W11 in the layer 3, this weight I am trying to update. And obviously when I'm trying to update the weight, guys, what is my formula? Derivative of loss with respect to, this is what is all about. So we can understand that when I want to update this W11, which is in the layer present in the layer 3, this third layer, so it is depend on O31, correct? O31. So what I'm trying to write is, rather than writing this simple formula of derivative of loss with respect to weight 11 in the third layer, I can rewrite this equation as derivative of loss divided by, now it is depend on this function O31. So I'm writing something as divided by O31 multiplied by O31 and divided by again W11. This is W11 in the third layer. So what is happening here? This W11 I cannot directly write as a single term. I have to write something in between, whatever encounter the terms I am encountering, and based on that subsequent term, this weight is dependent on. And this is what the formula I have written, guys, right? So if I want to update weight, which is present at layer 3 here, layer 3 in the hidden layer, so I have to take care of the output layer, and then from adding the output layer here at the output, and this output I have to add, and then adding this output multiplication and division. If you try to remove them, you will be able to get the same thing as derivative of loss divided by derivative of weight W11 third layer. Okay. So if you try to cross this information, because I am trying to going to multiply and divide by the same term, and what is my same term? This is a O31. O31, right? This O31, this is the term I am trying to multiply and divide. And you guys already know, if I try to divide and multiply by any term, it is going to remain the same. So that means what? I am trying to form a chain. So when I am trying to update this weight at a layer 3, that layer 3 weight depend on this, and that is why I cannot take the direct derivative. I have to take something called as derivative of loss with respect to O31 first, and then multiply by O31 divided by my respective weight. And this way, guys, this way, let's imagine that you want to update this weight. So how the formula will look like? So now this weight is, let's imagine this one. So weight at layer 1, right? So this way, if I want to update this weight will be depend on this O11, and this O11 in terms depend on O21, and this O21 depend on O31. So I have to update 1, 2, and 3. All these 3 steps, then only I can update this one, right? Then only I can reach to this weight. So the same equation will get added here. Let's try to understand. If I am trying to write this weight 11 at level 1 and try to write the same thing. If I want to update, so what I'm going to write, the weight with respect to dl with respect to first, I'm starting from here O31. So I'm going to write the same thing, O31 divided by O31, and then multiply by O31 derivative of O31. Okay, O31, then derivative of O31 depend on what? Derivative of O31 depend on O21. You can write O21 or weight W113, right? So I'm going to write weight depend on weight at layer 3, right? So I have just reached here. Then again there will be multiplication because I want to reach here. So in order to reach here, I just reach at the layer 2 here. So from layer 2, this weight will get updated. So that is, then I will update by something called as W11 at layer 3. Then divide by this W11 at W11 at layer 2. So let me denote that with the different color now. So I am going to update this term now. This term, right? This is my second term. This is my third term. And this is my fourth term, right? Or you can write vice versa. 1 and then 2 and then 3 and then this is 4, right? So I started from here, this point of time. So I am writing here derivative of loss with respect to weight at layer 1. So if I want to update at layer 1, this weight, guys, I have to start writing all the subsequent terms. So what are my subsequent terms? O31, then W11 at layer 3, then W11 at layer 2, then I'll come to W11 at layer 1. Okay. So this is what I'm going to write it here. You can see the same thing. I'm writing derivative of loss with respect to O31. This fourth term I am covering first. Then multiplication by same term, derivative for O31 divided by derivative of this term W11 at layer 3. W11 at layer 3. This is what I've written. And again multiply by the same thing. W11 into layer 3 weight. And this layer 3 weight now depend on what? So let me denote that with a different color now. So this weight is depend on this weight now at layer 2 weight. So this is what I am going to write again. So same thing I am going to write here, correct? So this I have written derivative with respect to W11 with respect to layer 2. Then I will try to multiply by the same thing, derivative of weight 11 at layer 2, 11 at layer 2, divide by now this depend on this one. So W11. So W11 at layer 1. So these many terms will get added, guys. Okay. So let me write it again. Let me write it again in a fresh manner. So this is what I am not going to rub here now. W11, this at layer 1 we are going to update. Okay. Let me write it the same equation and we are done. So we'll try to understand this weight I am trying to update. And for updating that weight, I have to add at this is layer 1, and this is layer 2, this is layer 3, and this is layer 4. Correct? So I'm going backward. I first try to include here O31. This is the O31 I included. Again, multiply by O31 divided by W weight. This weight at layer 3, right? This is what I have included. Then multiply by same thing. W11 at layer 3 divide by, then what it is depend on this one. So layer 2 weights, right? So I'm going to write that layer 2 weights. W11 at layer 2, correct? So then again multiply by same term, weight 11 at layer 2. Then this layer 2 depend on what? This 11. So I'm going to write this one. 1 at layer 1. Correct? So this many terms will get added, guys. This many terms will get added, and then this entire weight will get updated. And this was the simple path I was taking. Let's imagine if I want to take the different path, like the one I am trying to showcase you. So I am going to reach to this 031 first. I am trying to showcase this second path with the green circle now. So I will go to 031 first. From 031, rather than going above, I will go down. I will come to this 022. This is weight 21. Okay, and from weight to 1 I can again go to this layer weight 2, and from there I can reach to your layer, or I can take this path also, and this way I can go. So whatever path I am going to take, guys, whatever path, whatever neuron path I am going to take, that many weights will get added here. Where that many weights, if I am trying to take this path and then I am trying to include here, so I will try to include this path. What is this path? This path, rather than writing this one, what I am going to write then, so this W11, then it will not be W11, it will be W21. So multiply by W21 divided by, then it will reach to W11. So that many terms, simple rule, simple rule. So let me rub the things again. And simple rule, if I want to revise my chain rule, guys, so whatever weight you are updating, the subsequent weight term has to be get updated. And for that purpose, that many derivative terms will get added. So now let's take the simple example and revise. So if you want to update the weight which is present here, output 1, so it will be very simple derivative of loss with respect to 031. This is what we'll try to write. So, but if you try to write at this stage, then what is going to happen? So if you want to update the weight at this stage, this weight it depend on 031. So I am going to write something like that. 031 multiply by this W11. 031 again multiplication, then down we'll take this W11 at level 2. Okay. So this is what we're going to write. And now if you want to add this term, so obviously that term has to be get added. Again, I will try to add W11 at layer 2 multiplication divide by, then in the bottom you have to take this one. So W11 at layer 1. Okay. So this way, guys, one by one, all the terms has to be added. All right. So I guess everyone is now very well clear and very well aware that this weight updation process is not that simple. It is very complex. Actually, if you want to update a layer number 1, so you have to update the layer number 2, you have to update layer number 3, you have to update layer number 4, then only you can update a layer number 1. And that many complex derivative you have to take. So that is why, guys, the calculations are very, very complex, and that is why we try to understand that whatever the parameters we are generating, okay, something called as parameters. So whatever the parameters, like model parameters are W and X, and here in the calculation, guys, the calculation parameters will be this weights calculation, weights and biases calculation. So these many derivatives. So that is why if you try to create only 3-layer architecture, your entire weights and biases calculation will be around more than 4,500, guys. Minimum that many weights has to be updated in order to create a simple 3-layer architecture. So we're going to understand that immediately now. So we'll try to create this kind of architecture, and we'll try to understand how many weights are getting updated and how many parameters are getting generated, and that many calculation will happen, guys. That many calculation are going to happen. Guys, before we proceed, any questions, any doubt regarding this chain rule? So if I want to simply summarize, simply don't get confused, guys, about this kind of a derivative. Simple rule, try to remember. If you want to update any kind of a weight, at that time, whatever weight is there, that subsequent weight has to be getting added, then only we can update that weight, right? So if I want to update at a layer 2, obviously layer 3 has to be updated, layer 4 has to be updated, then only I can update 2. And that way, that many derivative terms has to be getting added in the derivative calculation of this loss with respect to weight, guys. That's the only simple rule, and that is called a chain rule. All right. So guys, just give me kind of a confirmation if any doubts, any questions out here for any kind of a chain rule concept. And then we are all done and all set to start with the designing of the architecture, guys, for our own neural network. So it is not the copy of anyone else. We are going to create our own neural network. And by using this neural network, we try to solve the 2 use cases. All right, guys. Thanks for Sau sir. Thanks for confirmation. Abhay sir, thank you. So let's get started, guys, then. So let me stop sharing the screen and let me start sharing my code window with you guys. All right. Just give me a moment. I'm going to try to start sharing this window. And by using this window, guys, we'll try to understand, all right, how to build our own architecture. All right. Yeah, I guess now guys, you are able to see my entire screen, right? So let's try to understand this one. How we can perform this entire things, right? So before we start, let's try to understand what kind of a data set I am trying to take here and what kind of a use case I am going to solve, and then we'll be able to understand how I am going to build around it one kind of a artificial neural network to solve this problem, guys. So guys, this problem, the data set which I am trying to take is called a churn model actually. I am going to build a churn model out here. Churn model. So churn model will, this data is obviously from the banking side. I am trying to take one bank customer data here, banking customer data. So this banking customer data is taken, guys, and this exited column, okay, out here, the last column, exited. This is my target actually. This is my target, and my entire objective here is to find out the churn prediction, to predict the churn. I'm going to predict the churn, guys, churn model. So what this churn model will say is whether my customer, okay, whosoever is my customer, let it be a banking data, let it be a retail data, guys, let it be any kind of a data. Sanam is asking if I want to create my own model by using transfer learning model and adding further layer and output layer. In that case, I am still using the weights of pre-trained model during the day. Yes, yes, guys. I will do. Don't worry. I have a entire code here, through where I have created my entire neural network using the pre-trained model. So I will try to share this code. I'll show you this code and I'll share this link with you guys. So you can check, like Sanam, you can check from there what is the entire steps we are taking. I have created one VGG16 model. I've taken that entire model and freeze that model's weight. Okay. Could you please take the image data set to create? Yeah, Nisha. Yes. I'm going to take both examples here. One is structured data and second one is I'm going to take the image data. Actually, the image data is solved, guys, something using computer vision technique. Actually, but still using the ANN, artificial neural network also, we're going to solve this problem. But actual, in reality, in the corporate, guys, what happens is whenever you try to solve the image kind of a data, kind of a video kind of a data, you build something called as convolution neural network actually. So this neural network we're going to understand. We're going to understand what do you mean by entire computer vision technique today. So I'll try to showcase you one of the latest and advanced model, latest and advanced YOLO model, YOLO NAS model. And by using that, we'll try to perform this kind of a entire object tracking and prediction. It's going to be very, very interesting, guys. So trust me, it's going to be very, very interesting since we are using latest of all the model, YOLO model, which is just recently launched in 2 to 3 months back. Okay. And I'll try to explain you entire concept, like how this entire YOLO model works. Okay. So don't worry, I'm going to cover, guys. Thanks for telling me this kind of a suggestion. Thank you very much. I will try to cover everything, all the models. Okay. So thank you, guys. And I'm going to showcase you same model we try to use. So whatever this model I'm going to build here, 3-layer architecture, same model we try to use for the image data as well. Is it possible number of image data take in a ML algorithm for? Yeah, it's possible actually. Some people tried that, but the model will fail most of the times actually. So model accuracy will not be good. Yes, possible. ML algorithm can also take the data, because what happens is, guys, whenever you try to parse data, in the end that data is getting converted into the numbers only. So as long as, see, what is my rule for the machine learning? Machine learning algorithm. Rule for machine learning algorithm is I have to pass the numbers only. I have to pass something called as my numbers only actually. Did accept only numbers. Let it be a text data or categorical kind of a data. You still go ahead and convert that into the number and then only you pass to your model, right? So it is possible because image is in the end getting converted into something called as a matrix, and which is a number matrix starting from 0 to 255. So it is possible. Pushpa, yes. But it model will not be able to do good, right? This is what people have tested. That's why they have a special model which is called as ANN here. So guys, let's try to understand this. Okay. So let's try to understand. I'm sure you will find it very exciting how the entire things works upon, how your entire face get appeared, how the entire detection process happens, and what happens in the background. Very, very interesting process. I'm sure you will enjoy this session. Don't worry. Entire money will be get paid, guys. Whatever. Obviously, these sessions are free, but like in Hindi, they say that paisa vasool. We'll try to perform entire these operations, and end of it, guys, you'll find it that entire worthwhile entire episodes will be there. Okay. So without wasting much of time, let me start the things. Guys, my data is this one. This is my target column. My target says whether 1 or 0. 1 means customer is going to leave and 0 means not leave. Okay, NL. So what is my data actually? This is my churn model data. I am going to build something called as a churn model. This churn model will be able to tell me in the future who are my customers who are going to leave the bank, who's no more gonna be the customers of my bank. And on the basis of this kind of a future prediction, guys, my bank will be able to take the proper decision how I can retain my bank customers, how we can retain my customers. That is what the decision my management will be able to take, and this is how it will help me. So for that purpose, let's try to understand. This is my target column, exited column, and all these my features, guys. All these are my features. Let's try to understand my features. What are my features one by one? So first is row number, second is customer ID, third is surname, credit score actually, not credit card score. Credit score, guys. Credit score. Geography means country he belongs to. What is his gender? What is the age? What is the tenure? Tenure means from how many years actually? From last how many years he is banking, performing a kind of a relationship with the bank, and then his tenure, that is called as his tenure with the bank, and then the bank balance, then number of products means how many financial products he's having, just like the credit card he's having, home loan he's having, a saving account he's having, all that kind of a product are called as number of products. Then there is a special column, guys, which is gauging whether that person has a credit card 1 or 0. Okay, and then whether that member is an active member of the bank or not, and what is his estimated salary. Okay, all these things are called my X, guys. X, and this exited column is my Y now. So this is my target and this is my features. All right. So guys, before we begin, and when you able to understand my entire data set by looking at this entire column, guys, can anyone tell me which column will be important to predict whether the customer is going to leave and which column will not be important? Looking at the column only, at a prima facie, at the first glance, can anyone tell me? So which column should I keep and which column should I remove? Okay. Age column, no sir, age column I'll try to keep it, because let's take this example that if someone is like a aged person above 60, so and obviously you guys already know in the India, like people are like on the pensioners, right? They try to prefer some banking system which is going to be staple one, like just like the SBI one. So they will have an account with the SBI and like they will try to keep it for next 10 years, 20 years. So because of their pension and all is getting credited in that kind of a bank. So that is why age matters actually, whether that person's age is there, that matters. Okay. Credit score and active members, important columns. Okay. You guys are telling me important columns. Okay. Their surname. Yes, surname is not important. That's why Rambo sir, yes, gender will be important, but the surname will not be important, guys. You can understand. I'm trying to find out which are my not important columns. So surname is not important. Gender is not important. You are saying, no, sir, gender will be important. Because what happens is usually, let's imagine this way. So some, if there, it is seen that there is actually a reference that whether this is a female customer or male customer, on the basis of that, they have proved that there is some relationship out here. So how we are able to perform that entire banking or not? Okay. Some ladies may like it SBI, some ladies may not like SBI. This could be possible because the SBI is a very slow bank and they try to retain like all the performing information. Surname, age is not important. No, guys. Surname is okay, Nisha, but not that one. So let's try to understand, guys. Let's try to how to important this data set in code. How to import this data set in code? Yes, I will tell you guys. Yes, I'll do it. We'll be keeping tenure. Yes, okay. Okay, guys. Okay, I will tell you. Okay, I will tell you. Don't worry. So, guys, let's look at this first three column. Actually, this is row number. It is illogical, actually, row number. I already have a numbers with me, row numbers. So, why I need a row number column. Then customer ID, not important, guys. Customer ID, and not going to predict anything whether this customer is going to leave or not. And also the surname, based on the caste, religion, nationality, doesn't matter whether that person is going to stay in bank or not going to stay bank. So these are my unimportant columns. I'm straight away, I'm going to move it, guys. Then you guys are asking me that how to upload this data set and import. So this is the code, guys. This is the code to import the data set. This is the code, import OS, and then for directory name equal to os.walk kgl.input. Because what is going to happen is if you try to click this one plus sign, I'm not going to click here because it will take my time. So just what you have to do is, guys, you just have to click here. If you don't want to write the entire this code will be automatically generated. Just click on the plus sign. There will be option which will be shown. Within that, try to choose the data. And once you click the data, guys, you can upload a CSV file there. And once you upload the CSV file, this kind of entire path will get created. You can see in the bottom. Okay. So if you are able to see the bottom, Kaggle inputs churn modeling. This is my project name. And within that, the churn modeling.csv. So this kind of a path will get automatically created by this kind of a code, guys. You don't have to worry about it. You just upload by using plus sign. There will be option to upload the data, Jupyter notebook or anything. So you can just choose data and upload a CSV file and your job will be done. Entire this first line of a code will be generated. Don't worry, I'll share this code with you guys. Okay, you can upload this code also. You can use the code. You can use this button also in Kaggle. Okay, I am using Kaggle, guys, for this running this. Then I will use the Google Colab as well for the image data. Okay, both the things I am going to showcase you how to perform the coding there. So first row is responsible. This entire first row of the code, guys, is responsible to import my data, and this will be generated automatically if you try to go by this shortcut by the VI, or if you don't want, you can use this way. You can use this path. You can directly use this code, and whatever the file uploaded here in this entire notebook, okay, wherever this notebook is saved in the same directory, guys, in the same directory, if you have uploaded this CSV file, it will try to read it by using this code. Okay, you just have to write the directory name and the file name and your job will be done. All right, so once I import that, guys, and or you can use this way also. See here, so this path is actually getting created. Okay, let me cut this file actually. So this path is getting created, or you can directly write this pd.read csv, and here you pass your path wherever you are trying to save the file, and followed by the file name here. Okay, this is churn modeling.csv is my file name, and this is my entire path, guys, where I've saved my entire, okay, the path where I've saved my CSV file. And this way you can upload directly, and you can call this as a data frame, guys. All right. So once I call this data frame, what I'm going to do is, guys, I'm trying to check my heading. By using the heading, I immediately come to know my first three columns are not important actually. Row number, customer ID, and surname is not important. Other things are very important, like geographical location, based on the geographic location. Because see, what happens is some banks are performing very good services in the Maharashtra. Some banks are doing very well in the like Karnataka. Some banks are very good doing in Chennai. So because it depends like what kind of a bank is going to give us what kind of a services. And based on that, if you try to come to Maharashtra, guys, in Maharashtra, people are very popular banks are some Bank of Maharashtra. If you go for the nationalized bank, and there will be SBI, and then followed by ICICI and HDFC and other banks, right? So this is what the entire top rating is there. If you go to Hyderabad, obviously the Hyderabad State Bank will be very famous, and then followed by SBI and the other local banks, right? So this is why this nationality, this locality also matters. So that's why we're trying to keep a geography location. And then gender, I told you, gender also matter. Then age, I told you like how it matters. Then obviously, guys, if the tenure is more, obviously that more likely that person is going to stay in the bank. If the tenure is less, like imagine any young person is opening a account in the bank, he just received a let's imagine that he just received one kind of a what you can say employment, and that because of that employment he's opening this kind of account because their company is asking them to put the salary account in particular so and so bank, and then immediately when he switch the bank, he will be able to switch the account as well, right? So that could be the possibility. That kind of a possibility they're trying to take care. So that's why they're trying to understand the tenure. If the tenure is more, it's more likely that this person is going to continue. Then obviously the bank balance. Bank balance is zero means, guys, is more likely that this person is not interested in the banking, right? And then a number of products also denote the same thing. Whether the person is having more product or credit card is more likely that he's going to be staying in the bank, right? And then whether he's active or not active member, obviously this is very important. And what is his salary? Based on the salary also, guys, we can understand there is a relationship. All right. So this kind of a column I'm going to keep, guys, and then I'm trying to check my describe data df.describe, and this will be able to give me how many counts are there. I can see 10,000 records I've taken, 10,000 records for this entire bank data I've taken. And then I have a 14 columns. I'm checking my shape as well, 10,000 into 14, and then I'm trying to check my describe column using which I can understand what is my mean value, what is my count value, what is my max value, what are my 50% quartile, everything. This information will help you to understand or judge the way the columns are, or whether I will be doing some kind of a feature engineering or not. Okay, how to clean the data, everything, that kind of a strategy I will be deciding. If I have certain NA values or something like that, I'll try to input them, remove the duplicates and all that cleaning will be done, guys, and immediately I'm going to remove these columns. You can check these columns. I'm trying to remove this row number, customer ID, surname. I'm dropping here df.drop columns equal to this. Once I drop, guys, now the data looks very good. Now what I'm going to do is I'm going to check that now, guys, very important that before we start to build our model, these two columns, if you try to look at these two columns are text column actually. So I have to convert them to the numbers actually, and then only I can start feeding my data to my model actually. right? So this is what is going to happen. Now I am going to convert these two columns, geography column and gender column, into the number by using something called as get dummies, one hot encoding, or something called as one hot encoding, or something called as label encoder. This kind of a two function I can use, and I can convert them, right? So this is what I am exactly going to do, guys. And then I'll try to separate this as my y, and I'll try to separate other columns as x, and then I will call my model, and I'll show you how to build a artificial neural network then. All right. So first thing, what I'm going to do is I'm going to check my geography location unique values, because this country. Then I can have found out there are only three options: Germany, France, and Spain. These are my unique values, and these are my counts actually. And then for the gender column, male and female, only two categories are. Then what I'm trying to do, I'm calling my function get dummies by using one hot encoding. I'm calling both the functions geography and gender. What will happen, guys, in get dummies? In get dummies, whatever the unique values are there, that many columns will get added. You can see here. So unique values are Germany, France, Spain, and here male and female. So I have received a Germany, France, Spain column, or n-1 column is possible. Okay. So this Germany and Spain column get added, and then one more column added like gender. In gender, if it is 0 means it belongs to female, and 1 means it belongs to male. And similarly, here the encoding will be done like this way. Germany 0, Spain 0 means it's more likely to the France value, right? So this is how the encoding will be done, like 100 or 0 here in the male column shows that it is a female. It is a female category, right? So this kind of a encoding is done, that many columns are getting added here. Then I calling this function pd.get dummies and passing my column names here. See, simple. pd.get dummies, and this extra column is getting added out here. You can see here. And these are the two columns because I had a three categories here in the country location, right? And here is only one column because I had a two categories. One column is more than sufficient. I can make it on off like 1010 by using 0 means other category, 1 means that particular column category, male category, this way. And similarly for Germany and Spain, if it is 00 out here means it is likely to be a France. This way I'm trying to perform encoding, guys. All right. So I think everyone is clear what encoding I've done. Then, guys, I am splitting my data. You can see here, I am calling my exited column as y here, and then other column, all other column from here, other column from here to here, except this exited column as my x, my features. Okay. And once I perform this x and y, I am calling my train test split function now. So what it is going to do is it is going to convert that whatever 10,000 records were there, out of that 2,000 record will be kept for the test, and 8,000 records will be taken into the training purpose, right? So this is what I have done, guys. Until now, just I have cleaned the data. I have created my entire feature engineering, and I have just created the things. Okay. I have just not started even building my model. Now going forward, I'll build a model. And before that, you can check here. One more thing, very important. Like we are trying to understand end-to-end model building. So here, if you try to look at some columns, this balance column, okay, and estimated salary columns. So this is a huge difference between the values. The values which are there are very large differences. So because of this, my model will become biased. My model will get biased towards these columns, because what will happen? A small change in the estimated salary will create a higher impact. In my wide prediction, guys. And this same way with the balance, because if you try to look at the credit score, it is in the maximum thousands. This is in the 10,000, 20,000 up to 1 lakh, and this is more than that actually. So this kind of a disparity between the columns, is going to influence my entire modeling. Very high chances that my entire prediction will get entirely modified by using these three columns only, and these other columns will get a very less weightages actually. Though this is not the case actually, I want to give a equal weightage to everyone. So that is why immediately what I am going to do is immediately I am calling my scaling function, standard scalar. So see here, I am calling my standard scalar, and by using standard scalar, guys, you can see here scalar dot fit transform. I am transforming my entire column, and what kind of a transformation I will try to do without losing the information. I try to transform this value between the 0 to 1 scale, or some kind of a same scaling transformation I am going to do, guys. And this is what I have done, and then my actual model building part will start, guys. Then I am going to create something under my artificial neural network now. Now it's a very interesting to understand how to build this now neural network, right? Until now, we have just done the pre-processing. We are just scaling, and then we are trying to understand which are important column, which are not important column, data cleansing. This is what I have done until now. All right, guys. So then what I'm going to do is now, let's try to understand how to build the actual artificial neural network now. Okay, this is what we're going to start now. So let's try to have understanding around it. This is my first package. Guys, I am going to use the frameworks actually. The frameworks which are developed by the Google actually. There are two kind of a frameworks. One framework is called as TensorFlow, TF, okay, TensorFlow. And there is one more framework which is very famous, which is called as PyTorch actually. PyTorch, okay. PyTorch is developed by the company Meta, which is previously called as Facebook. Now, and this TensorFlow framework, guys, it is developed by the Google. Actually. So what we're going to do is we're going to use the TensorFlow as our background. This framework we are going to use. By using this Google's framework, we're going to build this entire ANN, artificial neural network, guys. All right. So in next time, when I'm trying to show you the computer vision, at that time we're going to build something called as convolution neural network. At that time, I will use this PyTorch network so that you guys can able to understand both the frameworks, how to use both the frameworks. All right. So first thing, I'm going to use this framework developed by Google, TensorFlow, and in computer vision techniques, I'm going to use this PyTorch, guys. All right. So both the frameworks I will try to show you. Don't worry. So what I'm trying to do, first thing is I'm going to import my TensorFlow framework. In the TensorFlow framework, guys, there is a high-level API which is called as Keras. Keras is a high-level API. High-level API. What is this high-level API, Keras? Because in TensorFlow, it is a very difficult coding actually. Like I told you guys, Tensor, what is the meaning of tensor? Tensor means, guys, it is a three-dimensional array, or not three-dimensional actually. We can call this as more than three-dimensional array. So it is called as n-dimensional array. The meaning of the tensor is n-dimensional array, ND array, n-dimensional array. So whatever input you are passing, whatever data you will be passing, that will get converted into this kind of an array, which is an n-dimensional array. And then the processing will be done in the background. And there is a separate processor, which is called as TPU, Tensor Processing Unit. TPU will be able to perform this calculation, matrix multiplication, minus, subtraction, weight updation, and everything. All right. So that is why we are using this kind of a library, which is called as TensorFlow in the background. And in the high level API, like the English language, we are writing the things. For that purpose, it is a sophisticated API, kind of a framework or package you can understand. This is called as a kind of a package, Keras. By using the Keras package, just writing the similar English like a statement, we are going to build the Python coding. Okay. So for that purpose, I am calling my Keras now. All right. So everyone understood TensorFlow is my background actually. So why TensorFlow? Because every data information will get calculated into this tensor, which is a n-dimensional array, and then it will be able to perform using the TPU, Tensor Processing Unit, just like the GPU. Okay. This is what is going to happen. And then we are going to call this, where we take from that TensorFlow. You don't have to take, guys. You don't have to take. It will do the calculation in the background. You just have to call this Keras. You just have to call the sequential. That's it. It will do the calculation in the background for you. Don't worry. I'll explain you. Okay. So let's try to understand, guys. First, I am calling my Keras. Then first, I am calling my TensorFlow. From TensorFlow, I am calling my Keras. And from Keras, this is my model actually. Sequential. Sequential is my model name, guys. Algorithm name. Just like we have a logistic regression, just like we have a decision tree. That's same purpose. Okay. Yeah. Thanks, Pushpa, for that. So guys, same way we are calling our model. Model name is sequential, guys. Let's try to understand. Even if you're building an artificial neural network, even if you are building convolution neural network, or you are building a recurrent neural network, RNN, any kind of a network you are building, guys, we are going to use the same model. Model name is sequential. It is going to same. I will be able to make a code walkthrough also tomorrow for CNN. At that time also, if you are using a Keras, you will be using the same model with the model name is sequential, guys. All right. So model name will be sequential. Then in sequential, obviously, what you have to create? You have to create an input layer. You have to create an output layer, and you have to create a hidden layer, right? Hidden layer. So for that layer adding, we are calling something as from Keras, we are adding layers, and layer name is dense layer. Dense layer. Dense layer means we are creating an artificial neural network. So if I use a convolution neural network, I will call something else convolution 2D or convolution 3D neural network. Okay. So when I'm trying to call the other layers, which will be RNN layers. Okay. So that is why we are calling dense layer, which talks about the ANN, which talks about how to add input, hidden, and output layer. Okay. So let's try to understand now. Now I have imported my packages, I imported my model, everything, and I imported something of functionality called as dense, which will help me to add the layers, all the layers, input layer, output layer, and hidden layer. Okay. All these layers will be able to understand. Now, guys, what is the next immediate step we have to do? And let's try to understand what I'm trying to create here. I am going to create this kind of architecture, guys. Input layer, then followed by hidden layer, and then followed by output layer. This kind of architecture I am going to create. I will create only one input layer. Then I will be creating two hidden layer, guys. Then I will be calling one single output layer. This kind of architecture I am going to build. Now within this one input layer, guys, I am going to call something called as 11 neurons. 11 neurons I will be creating here. This way there will be 11 neurons in the input layer. Then hidden layer, there are two hidden layers, hidden number 1, hidden number 2, guys. And in the hidden layers, guys, what I am going to do is I am going to call 20 neurons each, 2020 each. 20 in hidden layer 1 and hidden layer 2. And in the output layer, guys, I have taken only one here. You can see in the output layer I have taken only one. So this kind of architecture I am going to create. So I think everyone is now clear what kind of architecture we are going to build. This is the 3-layer architecture only, not 3-layer, actually 4 layers. If you try to go by the layers, but the architecture is 3-tier only. 3-tier architecture is there. 3-tier architecture. A tier 1 is input, tier 2 is hidden, and tier 3 is output. In the input layer, I am taking only one layer. In the hidden, I am taking two hidden layers. And in the output, I am taking only one output layer. But number of neurons, okay, here I am taking one neuron. Here I am taking 20 neurons each for every layer. And in the first layer, I am taking 11 neurons, guys. 11 neurons, okay. So this is kind of architecture I'm going to build now, okay. Let's try to understand how to build this kind of architecture. Now, there is no limit. You can take any hidden layer, any number of neurons. But there is some logic which you have to associate, how to choose this kind of a things. Let's try to understand the coding, guys. Let's try to understand the coding and how I am going to create this kind of architecture now. So guys, first thing, if you try to look at it, what I am trying to say is, let me rub the things again and let me write it in a better way. Actually, in the bottom, in the above, right? Actually, I will write this input layer, hidden 1. This is hidden 2, and this is my output actually. And then I try to showcase you the code also associated with that layer. Okay. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 layer. I am taking 11 neurons. I have taken. Then hidden, I am not going to call every 20, guys. I'll show you only some, but try to understand. And here I am trying to take one. So this way, here 20 layers, 20 neurons. Then again in layer 2, hidden layer 2, 20 neurons. And then in the end, guys, I am taking only one. So this kind of architecture I am going to create here. Let's try to understand how to create and which code belongs to what kind of a layer and what kind of a visualization also. We'll try to understand. Okay. So this kind of things, and this end, this is my output layer. And out of this, I'll get my y head, guys. Right, okay. So this is what I am going to create. See here, first thing what I am trying to do is I am calling my model. Model name is sequential. This is what I have assigned, sequential function first, okay. So once I add a sequential function, guys, my immediately next job is to add my layers. Add my layers to in order to build this kind of architecture, right? So my layer number 1 will be added. Layer number 1. What is my layer number 1, guys? Input layer. In input layer, how much neuron I am taking? 11. So see here, what I am trying to do. Once I call my model sequential, I am saying model.add. Model.add. And what is my function to add the layers? Dense. So I am calling my dense function. All right. I am calling my dense function. And within that dense function, if you try to look at this neurons, I am taking 11 neurons. Now my question comes to you guys. My question comes to you that why I am taking 11 neurons. Any logic you can associate, anything, any logic you can come up with that why I'm taking only 11 neurons. Now, why not other 20, 30, 40, 10, 100, 200? Why not? Why not? I'm taking that many numbers. Why I'm particularly going for 11 neurons only? Any logic, anything you can associate, guys? Quickly, can anyone tell me what could be the logic? What could be the reason? I'm taking only 11 neurons only. 11. What is the logic? Can you come up with some logic, guys? Why I'm taking only 11 neurons in the input layer, guys, when I'm trying to add an input layer? And meanwhile, you guys answers me. Let's try to understand that. There is the activation function I am taking along with the number of neurons. First process is here, number of neurons. Okay, number of neurons. Then I am taking my activation function as linear and I am passing in my input dimension here. Okay, so this is my input layer, guys, IP layer. This is how I am adding my IP layer. Guys, can anyone tell me the logic that why I have taken only 11? Why not I have taken 12, 13, 15, 14, 16, 200? Yeah, awesome, Rupali, awesome. This is the answer I was actually expecting. Yes, ma'am, very, very correct answer. So why I'm taking 11, guys? Because of the logic that number of features or number of columns. Let's try to understand whatever data you are taken out of that, whatever number of columns, whatever number of features were there, after that converting to that text column whatever the text column, country and gender was there, converting them to the number. Okay, by using that, we have created some 2 extra columns, 2 to 3 columns, 4 columns actually, 2 columns for these countries and 1 column for this one. So 3 extra column we are created, and using counting that all the things, guys, my number comes to 11 actually. 11. That is why I've taken 11 input. So what is the logic here? In input layer, minimum take those many neurons. Minimum number of neurons. Minimum number of neurons should be at least as equal to number of features or column. Okay, so that is the logic. That means neurons you have to guess. Okay, so this is what I have taken, and then let me rub these things and let me tell you the next thing now. So this way successfully we have added something called as my input layer now. All right, so this entire first line of the code is talks about the model, and in the model, guys, I have added something called as my input layer. Successfully added my input layer by using this first line of code. Then, guys, second line of code, this code now talks about the hidden layer 1, and this second line talks about hidden layer 2 now. How to add hidden layer 2? Now like to understand that I passed here input dimension here, guys. Why I am passed input dimension here? Because that is also good question, that if I am passing image, how should I decide? Yes, I'll come to know. I'll tell you guys how to do that. You don't have to do that. the algorithm, we have provide one kind of a tweak to the coding, so that the algorithm will be able to take perform the calculation and will be able to take the neuron. Okay, I will explain that, guys. Don't worry. In coming 5 minutes, I'm going to explain that logic. All right, guys. So when I'm trying to build my things, I have built first my model. Then after model, I have added recently my input layer, and I have taken, guys, 11 neurons. Okay. Then, guys, what I'm going to do is I'm calling something called as model.add again. So what you have to write? Model.add only. Then you have to call the same function dense. Now, guys, what is the difference between all other layer adding? And because if you try to look at the function is same, model is same, every this activation function is also same, but only difference you can see here is number of neurons are getting changed. Number of neurons are getting changed. So how it will understand that which one is my input layer, which one is my output layer, and which one is my hidden layer, guys? Let's try to understand. Whatever first layer you pass, it will consider as an input layer. And but in input layer, we are trying to perform something, some kind of a parameter, which is called as input dimension. This parameter we are only taking in the input layer. That is how it will try to understand that it's a input layer. And then also kind of activation function. You try to look at it. Activation function which you are passing, guys, that it is 11 is number of neurons, guys. This 11 is number of neurons. Okay, number of neurons. How many neurons you want? Okay, so that is the number 11 here. Then the first layer, guys. All right. So this 11 is number of neurons we are passing. How many neurons we want, right? Like this one. So we are creating 11 here, right? This is what I've written in input. I'm taking 11 neurons. Then in the hidden, I'm taking 20 neurons. In the last, I'm taking 1 neuron, guys. Okay. This is what I have written here. See here. So it is able to understand, guys, how it is able to bifurcate between the input layer, output layer, and hidden layer by looking at the number of neurons here. You can see here model.add dense equal to 11, then activation function linear. This activation function also play very important role. You guys already know, right? In the first input layer, I'm taking linear because I'm not trying to perform any scaling, anything as such. Already done the scaling. I am taking as it is. So that is why I'm taking f of x, means as it is, whatever function will be taken, same value will be returned back. And then I'm taking activation function linear, and I'm mentioning this parameter input dimension equal to 11, means minimum 11 neurons should be there. You can take a maximum also, doesn't matter, but minimum that number should be present. Okay, then only you'll be able to accommodate all your columns, okay, in the input. Then, guys, I'm adding model.add dense, again same code, everything is same, guys. Apart from this input dimension parameter, you will only take in the input layer. Then you passing dense equal to 20, activation ReLU. Then same line I copy pasted here at the third line. So this is model.add dense 20, activation ReLU. That's how I added my hidden layer 1. I hidden my layer 2. And in the last function, guys, in the last layer, which I created output layer, I have taken only 1 neuron. Okay. So if you try to look at it, now let's try to concentrate here. And now I want you to answer me that why I'm taken only 1 neuron here. In dense, model.add dense, I'm only added 1, and I'm passing my sigmoid function. Now, if you try to look at activation function, in the hidden layer, I've taken ReLU. Here I'm taking sigmoid, and here I'm taking dense equal to only 1 neuron. One single neuron is taken, guys, here. One single neuron in the output layer. Why? What is the reason? Can anyone tell me? Why I'm taking only 1 neuron? Why I'm not taking, like in hidden, I'm taking 20. Here I'm taking input, because of input, I'm taking 11. Then why I'm taking single neuron, one single neuron, guys? Yeah, awesome, guys. Sanam and Rupali, yes, awesome, guys. So it is a binary class classification. That's why one neuron is more than sufficient for me. So I am taking dense now. And sigmoid, because of the same reason, since this is a binary classification, I am taking sigmoid, guys. All right. So this 4 line of a code, guys. Now, can I rub this thing, guys? Now, everyone is able to associate what line of a code belongs to what, right? So let me rub these things now. So guys, within the 4 line of a code, this 4 line and this model, you are able to build your entire ANN architecture. So once you are trying to write this code, guys, what you have to do is you just have to write this code and you have to run this code, and then you have to call something called as model.summary. You have to write model.summary, and this summary will try to give you an entire architecture. See here, I'm calling my model.summary, and then summary will give you what is the layer you have added, how many neurons you have added, and how many parameters are generated. This is old one actually. So don't go by this, and the correct value will be this way. Guys, dense one. So this will be 11. Here it will be 20. Here will be 20 and this is 1, guys. All right. So this here 20 means it is going to create a more parameters here. So it is 20 means it is 20 into 11 multiplied by this means 1032. At least minimum this many parameters will get generated. And in the end, rather than 400, guys, we'll have something around 1500 plus. Okay. Plus some neurons will get, parameters will get added. So what I have done now, check. You can check your entire confirmation. You can perform a confirmation of your entire modeling by using model.summary. You can see dense. Then in the dense layer, I am taking 11 neurons, and how many parameters are getting generated? 132. Then I am taking my second dense layer. So where I am passing my 20 neurons, you can see 20 here, and number of parameters will be around 1000 plus. Okay, 1000, 1K parameters will be get generated. Here also 1K parameter will get generated, guys. And then in the last layer, you can see 1, and number of parameters are generated 12. Okay. So this out. Now my question is, guys, now you can see the entire summary. Now you can have an entire confirmation that yes, whatever code I have written, this is able to generate me the successfully architecture what I am looking for. Now, guys, my next question comes to that when I am trying to see here. So what it is written here, trainable parameter equal to 408. Let's take this 408 means 1408 parameters are generated, because here I am taking less neurons. So if I try to add more neurons, what will happen? So 1400 plus taken trainable parameters. So can anyone tell me what are these trainable parameters to me? Now I have remaining only 2 line of a code is remaining, and that's it. My job will be done, guys. Okay. So can anyone tell me what do you mean this trainable parameter 1400 plus trainable parameter? What it denotes, guys? Now, what this denotes now? Can anyone tell me? Any guesses like what this should be denoting here? 1400, something like that. These trainable parameters are there. Means what? What they are trying to show us here. Can anyone tell me, guys, quickly? So what it should be telling us, that why we are taking this 1400 trainable parameters means what? What kind of a parameters they are talking about here? Can anyone tell me? Weights. Awesome, sir. Rambo, sir. Correct. Dr. Rambo, sir. Correct, sir. Correct, Dr. Ram. Yes, correct. It is correct. So we're talking about that many weights. That many weights and that many biases, guys, will get added. Bias will be obviously one in the one equation, but weights will be more, right? So that many weights and biases we are talking about, 1400 plus calculation will happen, guys. And in that calculation, if it is a chain rule, if we try to understand the chain rule, if I try to apply the chain rule and that weight is lying at somewhere at the layer 1, guys, that will be, yeah, guys. Dr. Anuja, correct. Connection between the neurons. Awesome answer. Thank you, doctor. Thank you, Anuja, Dr. Anuja. Thank you very much for your response. Thank you, Ram, sir. Dr. Ram, sir, for your response. Correct. You guys are really correct. Answer given. So let's try to understand if this many calculation has to be performed just for the 3-layer neuron. 3-layer neuron. 3, not 3 exactly, 4, because 2 hidden layer I have taken, 1 input layer, 1 output layer. So number of 4 layers I have taken, that 2 very small neurons I have taken 20. And then if you try to see this kind of a parameters are getting generated means, and this weights and biases calculation will happen, and that many times I have to take the derivative of loss with respect to weights that many times, right? And let's imagine if it is sitting at layer 1, obviously whatever sitting at layer 1, 2, 3, all these parameters have to get added. That many complex situation will be there. That many terms will get added, right? So that many terms will be getting added, and that calculation will happen. Let's try to understand. So that is why, guys, even though it looks very simple, in the background there will be a lot of calculation will be happening, right? So this is where I have created an entire model. Then, guys, my last thing is I have to add my optimizer and accuracy function and my loss function, guys. So model.compile. Last thing is model.compile. take your optimizer. See here, I'm taking at Adam. You guys remember, right? Adam, Max, Ada Delta, stochastic gradient descent with momentum, SGD with momentum. So I am taking here Adam. Then I'm taking binary cross entropy because only binary class is there. Then matrix, obviously accuracy. So once I compile my model, guys, that's it. I will start training my model. Model.fit, pass your X train, Y train. Batch size 50 means I'm taking the batch of 50 each, and then I'm taking 50 records at one time. And then I'll be passing. Then epochs equal to 200 means please run this model 200 times and passing my 80-20 split here. And verbose one means it will be able to show you the progress out here like this one. All right. So the moment I pass, guys, my model training will start and it will get trained for 200 epochs. So you can try to concentrate here accuracy. This is my accuracy at the training and this is my test accuracy. Now look at it, how it is started. 69, 79, guys. And then when you try to go back one by one, all the epochs are started now. And it will try to reach to something around 200 epoch, guys. And end of the 200 epoch, if you try to look at the accuracy, validation accuracy means test accuracy and train accuracy almost same. 79, 79 means my entire model is fitted very well, guys. So once I train my model, I'm calling my model.predict and passing my test data. And once I pass my test data, guys, obviously you can see here all the probabilities are getting generated. So all the probabilities, I'll try to pass something called as y_predict.argmax means take the maximum probability as per the column wise, and then it will try to give me the accuracy score. Accuracy score equal to y test, y predict, actual minus predicted, and then it will be able to give me 80% accuracy. All right. So this way I have created my entire model. I have created my prediction, guys, and then you can plot your accuracy of loss and validation. Accuracy, sorry, this is actually the loss function of your train and test, guys. And if you try to look at them, initially at the 200 epoch, they started very high, and then they started bringing their loss to very, very close below, right? So this is how they are going hand in hand. This yellow graph and blue graph, they're going hand in hand, and you can see here the accuracy also. So at the end of the 100 epochs or 200 epoch, guys, it will be able to reach to 80%, right? And they both are merging together means your model is very, very nice. There is no overfitting, right? So they are going hand in hand, very, very close to each other. Means training and testing is performing very nice. Very, very close to each other, most close to the 80%. All right, guys. So this way I have created my simple neural network and it will be able to give me the prediction churn model, the same algorithm which we can solve using the machine learning. All right, guys. So very simple, right? Only 4 lines of a code, but the entire logic is very nice, right? How we perform. Now, guys, any questions, any doubt before I proceed and try to tell you how to check the import the same kind of a data, but this time we try to use the same neural network, but it will be a image data set, guys. Image data set, and I'm going to switch to my Colab notebook. So, guys, kind of give me confirmation quickly. So everyone now comfortable, understood how to train this model, how to import this model, how to build your own architecture. Now, what kind of a adjustment or what kind of a performance you can do here? You can change this kind of architecture by your own. You can try to input the different data set. You can try to take the different entire thing here. So instead of taking hidden layer 1 and 2, you can add more layers. You can add different number of neurons here. Not try to change the neuron the input layer because it depends only solely on the number of input you are passing. Please try to maintain minimum 11. If you want, you can take more and try to perform a experimentation in it. You try to add or minus or remove the things. Just copy paste this line and paste it and try to remove the number of neurons, add a more neurons out here, right? And try to perform a experimentation in the optimizer. Rather than Adam, try to take a stochastic gradient descent with momentum, try to take the different loss function, accuracy function will almost be same, and try to make the changes in the epochs and the training size, guys, and then try to perform a predictions. And let's try to understand how your model is performed well and try to understand, okay, by this experimentation, how your model is performing well. So this is very, very simple way, guys, how you can create your own architecture. So before we move to image data, please let me know if you have any questions, any doubts, anything related to the same architecture, and then we can move this. So is training, validation, and testing data unique? Yes, guys. Testing, validation data is unique, guys. That's why we did a split. You can see here. So when we try to train our model, before that only in hand, you can check here this line of code. I have created 4 variables: X train, X test, Y train, Y test, and passing my entire data set as a test size 80-20 means 10,000 records were there initially. This 10,000 records, all these 10,000 records, if you try to check the shape, guys, here. Okay. So these 10,000 records are there. 8,000 unique records are taken in the training and 2,000 records are taken in the test. That is what this test size denotes. All right. So here it is 60-20-20. No, guys, not 60-20-20. It is 80-20 only. So validation and the test is same, guys. One and the same here. because we are not creating 3 splits actually here. So it is 80-20 only. All right, guys. So I think no more other questions. If no more other questions, I can directly show you. Now it is same, guys. It will not take much time. So let me go to my collab now. Let me stop sharing and let me start sharing my collab notebook here with you guys. And you can understand in the same code and same kind of architecture, we'll try to build some around it, one kind of image data, guys. Very interesting data we'll try to take. Let's try to understand this one. Yeah, validation data is from the original data set only. What we're trying to do is, let me tell you, the Sanam, ma'am, sir, ma'am. Let's try to understand this one. So let's imagine if this is my entire data set. And how many data sets I had? 10,000 records, right? So what I did is, like, simply I created one kind of split here. So random 8,000 out of this has been pulled and kept it for the training purpose, and random 2,000 are taken. Also, these are unique and these are kept for the testing purpose. And this is what the split I've done from my original 10,000 actually. Okay, original 10,000. This is what I've done, guys. All right. So hope I answers your question for now. So guys, let's try to understand here what I'm going to do. Guys, this way we're going to use the same architecture. Okay. All right, guys. So we are going to use the same architecture, but this time what I'm going to do is I'm calling something called an MNIST dataset. Okay. Let's try to understand what is this MNIST dataset is all about. Okay. So what I'm going to do is, guys, let me show you this MNIST dataset. This MNIST dataset will be this way. So let's try to understand. If you try to look at this image, guys, there will be multiple images here. So we are going to take more than, I think, 10,000. You can see here 10,000 images we are going to take. So guys, this 10,000 images, what will happen is, in the 10,000 images, I am taken the digits from 0 to 9 actually. And all these images contain the different numbers written from 0 to 9. So could be 7, here could be 8, and could be anything. And this kind of a pictures I have taken, guys, images I have taken. And this kind of a data set is called as MNIST data set, AMNIST, MNIST data set. And this is very, very famous data set, guys. And where they have written a number of digits here, handwritten digits actually. These are the handwritten digits, guys. Handwritten digits are there. And this kind of images are there. So this 10,000 such images I have taken, guys. 10,000 such images I have taken. And this data I will be passing to my model. Same model which we have created there. That kind of a model, only 3 to 4 layer of architecture we'll try to create here. By using same libraries, everything will be same. Only the input will be different, guys. And we'll try to understand how this model perform and how kind of accuracy it will try to do. And we'll try to check whether it will be able to detect whatever the number written on the image is correct or not. So whatever number it is written between 0 to 9, whether it will be able to give me the same prediction or not. This is what we're going to check, guys. All right. So interesting data, right? Interesting data. Let's try to understand. This is how the images look like, guys. All right. So what I'm going to do is I'm going to clear all these things. I'm going to bring all the same libraries, sequential, Keras, TensorFlow. Now only one more layer I am calling here. Here. I'm going to call one more layer rather than from the dense layer. I'm calling something called as flatten layer now. Why I'm calling flatten layer? Let's try to understand this one. Okay, why this flatten layer exists actually. So guys, if you try to look at this one, if you try to see here, so when I'm trying to take my train data, see here, train 0, correct? Train 0 I have taken, means first index I have taken. So what you are able to see here, you can see this kind of a matrix is there, correct? So this matrix is starting from here and from here, right? So this matrix exists actually. Matrix exists, right? Matrix means my data is in this column, right? There will be rows, row number 1, row number 2, row number 3, and there will be column number 1, column number 2, column number 2, 3. Okay. So what kind of a shape is there? That kind of a shapes will be there. Okay. So if you try to understand my entire image, when I'm passing my image, guys, let's try to understand this one. My image get converted into something called as matrices, guys, always. So when this we'll try to make it very, very clear when we're going to understand this entire topic, guys. And today's computer vision technique, which we're going to start immediately now. But in 5 minutes, let's try to understand what is going to happen. So whatever image you are passing as, that image is getting converted into the matrices. Okay. So matrix could have any kind of a shape, could be like 3 by 5, means 3 rows, 5 columns, or something like that. Any kind of a shape possible. So when I'm trying to store my data, it is stored in the matrix format. But when I'm trying to pass that data, guys, when I'm trying to pass that data to my artificial neural network, so this way, so there are 2 hidden layers and 1 output layer. What I have to do is I have to create this kind of a flatten array. A stacking has to be done, a kind of a vertical stacking. So this vertical stacking has to them. So whatever number of rows and columns are there, I have to store them in this kind of a vector, guys. Kind of a vectorized format. This kind of a transformation I have to do. This is called as stacking actually, and this is called as flattening actually. So this entire operation is called as flattening. Okay, flattening operations. Flattening means what? Whatever matrix is there, that is a two-dimension, right? Row and column. That I am going to convert into one-dimension vector. So I am going to stack all the values. I've tried to take one value here. I'll try to keep it here. Second value, I try to keep it here. Third value, I try to keep it here. This way, all the rows will get accumulated here. And this kind of a vertical kind of a vector I am going to create. That operation is called as flattening operation. And then from this vector, one by one, all the values will be passed on as my inputs to my neural network, guys. Okay. So this kind of operation I am going to perform. For that reason, I am taken here the flattened layer. A flattened layer, guys. And dense layer, you guys already know, to create that kind of a data set, right? So that kind of a layers like input layer, all that layer, to add that layer, I have to create this dense function, right? So flatten and dense, these two functions I am taking, guys. Then what I am going to do is this MNIST data set is already available in the data set. This data set which belongs to 10,000 images, guys. You can check here. Shape 10,000 images of 28 by 28 size. Now 28 by 28 size means what will happen is when I am trying to convert them into the matrices, guys, there will be 28 rows and 28 columns. Okay, that is what the shape is there. And this such 10,000 matrices will be created. Okay, 10,000 into 3, guys. 10,000 into, because it is a color picture. So whenever we try to pass the color picture, it will get converted into 3 matrices. I will explain you all these things in upcoming computer vision technique. So guys, let's try to understand. I am trying to call my flatten layer. I am calling my dense layer. Guys, you already know now. So what kind of a flattening operation we have to do, right? So whatever image is getting converted into the one kind of a vector, and that information then will be passed to my neural networks, right? So for that purpose, what I'm trying to do is I am loading my data set from Keras. So Keras already have this data set, MNIST data set. I'm just simply creating my variables. X train, Y train, X train, Y train, X test, Y test, guys. All right. X train, Y train, X test, X test. I am calling my function keras.dataset.MNIST.load data. This is the function I'm calling load data. And from where I'm calling it as load data, dataset.MNIST.keras. That's it. So by this one line of a code, I'll be able to generate my entire data set, guys. And if you try to look at the test data size, it is a 10,000 images of 28 by 28 size, right? So this is what I have generated now. And then from this, if you try to look at the train, guys, in the training purpose, what you'll see the number of digits from 0 to 9. So this kind of a category will be there, 0 to 9 classes, right? So you have to identify between 0 to 9. So you will have this kind of a classes now. 0 to 9. This is in the training, and the testing, guys, we have images here. All right. So this is what my prediction should be, number from 0 to 9. And my image, this is what I'm passing 20 by 20, 10,000 images, right? So guys, then once I'm able to pass the things, what I'm trying to do, I'm trying to check like how my image data look like. If you try to image my, we are inputting my matplotlib library, and from the matplotlib library, I'm calling my function plt.show. I'm passing my training data, guys, and one picture I have taken randomly. And if you try to look at the picture, this is how the picture look like. This is what the handwritten digit look like, right? 4. All right, guys. So everyone now confirm that I'm taking image only, and such 10,000 image I'm taking. Now, when I'm trying to take the image, guys, what I told you that it will get converted into a matrix. So this will get converted into a matrix, and the matrix size will be 28 rows into 28 columns. And such 10,000 records I have taken. 10,000 records I have taken, guys, and this will get multiplied by 3 if I try to take the color images. All right. So this, let's imagine we have taken only this kind of a shape as you here. Then what I'm trying to do is I am going to take the data and going to divide that data by 255. Can anyone tell me, guys, why I'm dividing by 255 here? What is the reason I'm trying to divide by 255? Anyone can tell me quickly why I'm taking only 255 now? Why I'm not taking other values to divide it, my train and test data, guys? All right, let me see who has answered me. Due to RGB, awesome, Anuja ma'am. Due to RGB, what is going to happen is my minimum value is 0 and my maximum value will be 255 because these are my pixel values. These are my pixels, right? And pixel is nothing but kind of a dot, which I'll explain in upcoming lecture. So pixel from pixel, if you try to connect the pixel, you can try to create a shape. And from the shape, guys, the entire image is getting generated. That is the logic. So that's why I'm trying to take here. If you try to, let me rub these things. If you try to take the next image step, I'm trying to perform a normalization here. I am trying to perform the normalization step here. So for that reason, whatever the X I am taking, train divided by 255, test I am taking divided by 255, guys. X train, X test divided by 255, normalization steps I have done. All right. So this till now, guys, I am not built anything. I have just created a normalization. I have imported my data, saved them in train test. I have imported my library, guys. Now try to understand. This is how the normalized data will look like. Okay. So you can see the matrices here. All my matrices are shown here, guys. Huge matrices are getting created, right? So then, guys, then obviously it is same thing I am trying to do here, but only small changes there, guys. Though now, if you try to compare the coding wise, it is same architecture. Now only small changes are done, guys. I am going to create something called as my input layer only. I am going to call my hidden layer 1. I am going to call my hidden layer 2. I am going to call my output layer. Everything gonna be same, guys. Same 4 layers I am going to call. Only small changes you can see here, that instead of writing now in the input layer, rather than writing number of neurons, I am going to do a tweak. What kind of a tweak I am going to do? Let's try to understand. I am calling my flatten operation. Okay. Model.add. I am calling, guys, model.add. Okay. So guys, I am calling something called as model.add, and from model.add, guys, I am going to share, like Chandana has also shared in the chat box, the attendance and feedback link. I am also going to share the same link again in the chat box for everyone. So you guys can mark your attendance. All right. So please try to refer to the chat box and try to take that link and you try to mark your feedback and attendance, guys. All right. So guys, let's try to concentrate here. What I'm going to do is, rather than now writing the number of neurons here, like you guys were asking, Sanam was asking that how to choose the number of neurons in the input layer when I'm passing my data as image, right? So guys, rather than calculating this, what I'm trying to do, a smart tweak we have to do is, you have to call something called as your flatten operation. Then flatten operation, what we'll try to do is, whatever matrix you have created, that matrix will get converted into kind of a vector this way. This kind of a vector will get created, and you have to try to keep the values here. And this will done automatically by using this flatten operation. And in the flatten operation, what you have to do is, you just have to write the shape. So what is the shape of my matrix? 28 into 28, right? So this 28 into 28 matrix. So that 28 by 28 size, I'm passing my input shape here, and I'm calling my flatten operation here, flatten operation. And whatever calculation it has to do, it will try to do, and accordingly it will try to take the number of neurons here in the input layer. So this way I am relieved from the performing the calculation to choose the optimal number of neurons here. All right. So this is what I've done, and the other things are, guys, same now. But the only change what I've done is, now I've taken ReLU. Here also I'm taken ReLU, guys. And but in the last thing, so in the last thing, I'm taken number of neurons as 10 here in the output layer. And here also I'm taken more neurons. In the hidden layer 1, I have taken 128 neurons. And here I am taken something called as 32 neurons in the hidden layer 2, guys. All right. So guys, now if you try to look at this, now there is no logic, such logic, that why I'm taken 128, why I'm taken 132, why I'm taken, because now my data is very huge, guys. My data is very huge because I have a 10,000 matrices. I have a 10,000 matrices of size 28 by 28, and that matrix I have now converted into a vector. This flattening operation, by using the flattening operation, using the flattening operation, I converted them, and then I'm passing to my artificial neural network, right? Same thing I'm passing to my artificial neural network. So that is why I'm trying to take more neurons, so that all the calculation will be done very well. So that's why I'm taking 128 in first hidden layer 1, 128 neuron. In second, I'm taking more than that, 128 first, then 32. And then, guys, in the last output layer, I've taken 10 now. Number of neurons are 10 are taken, and the sort max function, now you can see here, instead of sigmoid, guys, I've taken sort max now. And the same way I've created my architecture by using sequential model only, guys. All right, can anyone tell me now? So why I've taken 10 now? Why I've taken 10 now? Why not I have taken 1 here? Like in previously, when we try to build that churn model, at that time taken 1 only, right? And the same architecture, same model, everything I am taken same. Only small trick I have done is flatten layer, and same code I have taken model.add dense, but only the neurons are changed. Now, can anyone tell me why? Yeah, multi-class classification. Awesome. Rupali ma'am, awesome. Yes, sir, awesome. So multi-class classification, we have a 10 classes. Yeah, who else has replied me? Yeah, Dr. Anuja. Yeah, correct, ma'am. Correct. So there I am trying to take the classes between 0 to 9, which is actually the 10 classes. That's why minimum 10 neurons we have taken, guys. Awesome. Okay, guys. So once again, guys, Chandana has shared the link. I am also sharing the same link out here in the chat box. Please mark your attendance and please mark your feedback, guys, out here. Right? So guys, this is my entire architecture. Then obviously you will call the same function model.summary, and let's try to understand now how the summary look like. And now this is the real time, guys, real time calculation. Now you look at the calculation, what is happening. That previous ANN, same here is also ANN, there is also ANN. Now, but look at the differences, guys. Flatten layer. If you try to take the flatten layer, guys, what I've done is, if I try to take the flatten layer, in the flatten layer, now you will be able to understand how many neurons it has actually taken, because I did not provide anything here. I just provided my flatten layer and provided my shape here, 28 by 28. Now, if you try to look at the number of neurons, it has taken 784 neurons on its own. Okay, and no parameters are generated here in the input layer. Then you try to look at the hidden one and hidden layer 2, guys. So here we have taken 128, here we have taken 132. And now if you try to look at this 128 first layer of the hidden layer, 10,000, not 10,000, actually 1 lakh parameters you can see here. Guys, 1 lakh parameter, 100480. So these many parameters are generated, guys. So only 128 neuron I have taken, hidden layer 1. And if look at the size, 784 neurons taken by its own. It has taken by its own by using flatten operation, and by looking at the huge data set, like we try to convert this, right? 28 into 28 size matrix into 10,000. So that many number of numbers were there that were fitted into this kind of a vector. So that is a huge vector, and they are created as 784 neurons in the input layer. And in the hidden layer, we have taken 128, here 32. And look at the parameters, 1 lakh parameters are created, means these many weights calculation will happen, guys. These many weights and biases calculation will happen here. 1 lakh, same thing, same neuron. There were hardly 1,000 or 2,000 calculation were happening. But the moment we have introduced the image data, guys, the moment we introduce the image data, the entire calculation went into the lakhs, guys. 1 lakh plus calculations are happening. And this is my last hidden layer, output layer, where it is creating 330 operations, 330 parameters, guys. So this way, I have 1,04,938 parameters. All right. So now try to understand the immense and complex situation, what is happening in the background, and by which way they are trying to deal with the entire image data, guys. All right. So that is why it is not that simple, that lot many calculation has to be done. And that is why now coming back to your question, guys. So you were asking me, can we pass image? Can we pass image to our machine learning algorithm? They will fail, guys. They will fail because of this. This is the reason I was talking about, right? So then, guys, now I think you guys can understand what are the limitation of the machine learning algorithm. This many parameter calculation is not that simple. All right. So then I'm compiling my model, guys. This time I'm taking my loss function as sparse categorical cross entropy, because it's a multi-class classification. I'm taking Adam accuracy, and this time I'm taking, guys, 25 epochs only. Small epochs I'm taken. Yeah, guys, I will share again. Shubham, I am sharing the entire link again in the chat box. You can refer here. This is the same link, feedback link, and the attendance link is same, guys. All right, guys. So this way I am trained my model, and now you look at the model. So this model has been trained, guys. After this epochs, you can check the accuracy. It has reached to around 97%. So after that, I am calling my same thing, model.predict, and then argmax I am taking. And now if you try to check the accuracy score, it has given a 97% accuracy. All right. So you can compare your loss function here. Orange one is for the testing, blue one for the training, and you can compare your accuracy, guys. All right, this way. Now you look at this thing. Now I am trying to pass one test data here, test data. So what is state data, test data? This is the image which is written 2 here. So same thing I am trying to pass this. Okay, I am passing to model.predict test image. I am passing, reshaping first, and then passing it. Now you can look at the output. It has correctly predicted. It has correctly predicted. It is a 2 written here. You can check here. 2 is written on this image. Awesome, correct. So hence it is proved that the same artificial neural network can be used for the image data, and same can be used for the structured data. But the number of calculations are very huge, even though I am using the 4 layers only. Even though I am using 4 layers only, the number of calculations is in the lakhs, and for the structured data, guys, it is in the thousands only. So that's the reason ML algorithm will fail, guys. All right, isn't it awesome, guys? What do you think? Same neural network can perform both. It is called as multimodality then, right? It can perform a structured data, it can perform the unstructured data, guys. All right, guys, I think you guys are able to successfully understand how to build your architecture. Same way, you can make the changes accordingly into this entire architecture. If you wish, you can go ahead and make the changes out here. what kind of activation you want, or what kind of input shape don't have to change because this is fixed. It will try to calculate on its own, but you can add and minus this dense layer. You can add and minus this kind of a functions. You can add and minus this kind of a loss function, optimizer, matrix accuracy. Rather than going for the accuracy, guys, you can go for F1 score. You can call your classification function. You can go for recall precision. Everything is possible like we have learned in the machine learning. All right, guys. So hope you guys have understood this entire thing. So can we start with the computer vision, guys? Please let me know if you have any questions before I switch on to computer vision presentation. All right. So I hope you guys have enjoyed how to build this entire neural network for both the purpose, image, for the data. All right, guys. Thank you very much, sir. I think these are my colleagues and professors. How to get the design of this entire application? It's up to you, Anuja, ma'am. Like how you have to create. Like I will tell you end of this lecture. There are pre-trained models also, so you don't have to think about this one actually. So what people have done is like they know that creating this. What we have done here, Anuja, ma'am. Let's try to understand here. So what? How do we face class imbalance problem in CNN? Can we face imbalance class will not face. I will explain this CNN Rupali ma'am. I'm going to cover this thing. Don't worry. At that time, you come to know your answer will be your question will be answered. And I think my colleagues from the Mangalore, Professor Sir are saying go ahead from the Mangalore. Hello, greetings for the Mangalore teachers, professors. So Anuja ma'am, coming back to your question is like whatever architecture we have created here, right? We have created everything from the scratch. Like we have designed each and every neuron, each and every layer we have designed. So this takes actually months and years of the time. We have to do a trial and error. So what people have done is they have come up with the entire models, and you what you have to do is you have to just that are called as pre-trained models. There are more than 20-30 pre-trained models are available. I'll show you where these models are available actually. So I will try to cover tomorrow one supervised learning model. We try to understand how to build that model for the face detection. Actually, I will show you the code walkthrough also. Today also I am planning to show, not today actually. Tomorrow I am going to start with the two messages. One for the medical data, people were saying me how to perform this medical visioning thing. So I have created one case walkthrough where I am going to show you if you try to pass the X-ray, if you try to pass the chest X-ray, okay, chest X-ray, so you will be able to detect whether it is a COVID situation or not a COVID X-ray. So whether this person is having COVID or not having COVID-19, okay. So that kind of a use case I'll try to cover tomorrow maybe, because today we have to start with actually concept of the computer vision. So tomorrow I'll try to make that code walkthrough for one for medical reason. One, I'll try to showcase you how to build a face recognizer using the pre-trained model. And then we want to understand also the YOLO model, which is very latest model. That is also pre-trained model, or we can show you a YOLO model, which is a pre-trained model, how to download that model actually. You don't have to create anything from the scratch, okay? That model is already created, number of layers are created, weight training is done. You just download that model, customize your data for whatever data you have, customize that for your data, and you can start using that. Now that is the simplicity for the pre-trained model, guys. Then coming back to the question of Sanam, cross-fold validation should be used for the evaluation for the model. No, here it is not you. If you try to go for cross-fold, what will happen is already we are having number of epochs, right? Many times this model is getting trained, and that many times our entire model is calculating the derivative. That's why I will not go for the cross validation. Yes, sir. I will again share this one. How and where we are going to share the link of code. Yes, I will share here also in the chat box also tomorrow, and I will also upload all these things for your future reference in the LMS. Okay, I will try to upload all the codes, all the presentation, every code, every link, every Jupyter notebook, every Colab notebook, every Kaggle notebook. We'll try to make it available for your future reference in the LMS, as well as I will try to share it here. Okay, I don't get a link. Okay, Anuja ma'am, you can speak to Chandana and she will share with you. Don't worry. Our technical team will help you. Guys, I am going to share again, once again, this feedback link and attendance link. Whosoever not got this link, please try to refer that. I have shared in the comment chat box. You can get it. All right. So I think I am able to explain. Yes, Anuja ma'am, I think I have taken care of your question. Attendance link, Hari Krishna sir, I have again shared in the chat box. I think you will find it there. Again, I have shared it. All right. I will share it again if you want. Attendance and feedback link is same, guys. So I have again shared it in the chat box. All right. So no further questions. All right. Yeah. Thank you, sir. Hari Krishna sir. Thank you. Okay, guys, then I think we are all good, all set, I think. Let's try to understand our next concept, which is called as computer vision. So at least we'll try to start with the computer vision today. And tomorrow I'll explain you the entire operation, how the convolution operation happens, how the actual picture is get convoluted, how the entire algorithm try to understand how the entire picture is there, how it is try to find out, extract the things and all. So it is very interesting. And then we'll try to understand how to build around it. So let me share my presentation with you guys, computer vision presentation. Very awesome presentation, a very awesome topic is there. So I am sure you will enjoy this as well. Okay, let me share the presentation with you guys now. Okay. Yeah, I think now you guys can see my presentation. So guys, this is the topic about the computer vision first. Now we are going to step into something called as now in the computer vision. All right. So we guys, we have seen now first ladder actually. The first ladder talks about artificial neural network. And here we were able to understand the forward propagation. We were able to understand the backward propagation. We were able to understand the loss function, optimizers, on all the problems we face, and the dropout layer also we were able to understand now. So once you have a basic understanding how the neural network works upon and how to build this kind of architecture for the image data and for the structured data, now we are going to the second advanced level, guys. Second advanced level. And this advanced level, now you come to know that now this is called something called as computer vision now, computer vision. And this computer vision, when I'm talking about, guys, I'm trying to talk about the convolution neural networks actually. Convolution neural network, this computer vision technology, this computer vision is nothing but an eye of a computer. You can say simply eye of a computer. And this eye, that's why I've taken this picture, eye of a computer. And by using this eye, guys, it is able to understand the picture, image, and video, everything. All right. So in short, if I'm trying to talk about the eye of a computer using something called as convolution neural network. Convolution. Okay, convolution is the operation name. Convolution neural network. Neural network, guys. Okay. So this is what we're going to understand. Convolution neural network, CNN. It is famously called as CNN, guys. And CNN nothing but it is computer vision, which you talk about, guys. This computer vision means it is a part of the eye of the computer, or you can say it is a ear of the computer, through which it can see, it can hear, and it can perform the task, guys. The tasks which are related to the video, the tasks which are related to the audio, the tasks which are related to the images. Okay, all these tasks will be done by using this kind of a neural network, and that entire concept is called upon computer vision. Computer vision means computer machines are able to see you, machines are able to understand you. They can bifurcate between the images, they can bifurcate between the videos, they can test the videos, they can understand the videos, they can recognize the videos, they can recognize the people, they can recognize the object, they can track the object, they can check the object. Okay, so this is what is called as computer vision. Now let's try to understand computer vision. So let's take some example, and by using the example, guys, we'll be able to understand the computer vision. What is this computer vision technique is all about? And very, very interesting topic, guys, very interesting. And I'll make sure that you'll find it very interesting, because I'm going to use the latest model, which has been released 2-3 months back only, in the month of like 4 months back only, June, July, end of July, it has been released, YOLO model. And we'll try to understand the YOLO architecture as well tomorrow. And we'll try to implement that YOLO model for detecting the video and detecting image, guys. Awesome. You'll try to understand, you'll find out. This model is one of the sophisticated model, guys. One of the state-of-the-art model, SOTA model. State-of-the-art model, state-of-the-art algorithm model is there, YOLO. We're going to understand this YOLO model implementation, YOLO, and especially in the YOLO, guys, something called as YOLO NAS. Actually, NAS, YOLO NAS. NAS stands for Neural Network Architecture, Neural Architecture Search, guys. It is one of the advanced model, and we'll try to understand the model that, okay, we'll try to implement that model. Now, guys, when I'm trying to talk about the computer vision, coming back to a question that computer vision, let's take the simple example. This medical field, okay, if you're trying to pass this kind of a image, okay, this girl's image, and then once I'm able to pass the image, guys, I'll able to convert that image into this kind of a thermal image. This kind of a thermal image by using computer vision. And if you try to convert this thermal image, eventually if you try to see this kind of a white spots here, so these white spots are nothing but this kind of a reddishness which is available on the face, guys. And by using this kind of image, it will be able to understand what is the problem with the face, and by entire face X-ray will be created without any X-ray machine or without any kind of a high cost equipments. High cost equipments are not required, thermal cameras are not required. I just pass this image, I just pass my color image, it will be able to generate a thermal image, and it will be able to tell me is there any inflammation level is happening Is there any kind of a temperature is there? What is the problem with the entire space? And is there any white spot? This kind of a white spots are detected, and it is trying to showcase that there is some problem with the face. There is something going on, something wrong in the picture, something wrong in the face, right? And this way, guys, it is able to identify the anomalies. It is going to identify the anomalies in the entire medical imaging. In the medical imaging, it will be able to detect something going wrong with your face, and immediately it will come to know, guys. So this kind of a things, this kind of architecture, it is one use case where you pass your color image, it will be able to convert it into the thermal image. By using thermal image, it will be able to detect the anomaly, it will be able to detect the problem, and then problem can be also help to detect what kind of a disease it could be, what kind of a disease it could be. So this could be one simple example, guys, where you can find out the medical imaging use case. Let's take this example, guys. If you try to look at this example, this is from the agriculture field. Now you'll try to understand how the agriculture is getting impacted by the AI, by the computer vision. Okay. So let's try to take the simple example. This kind of robot, if you try to look at this, guys, this is a robot actually. This robot is AI enabled robot. Now what this robot is doing, let's try to understand. If you ever heard of these videos or seen this kind of a video, that they have created one kind of a robot out here. This is the robot arm, and on that arm there will be one camera here. So this is the color camera, and by this camera, guys, let's imagine what is happening. They are trying to run this entire robot or kind of a drone out here. Okay, so this kind of an entire drone or robot is they are taking it to the farms, guys. And let's imagine what is happening in the farm. You guys already know, right? So if let's imagine you have a mango farm here. In the mango farm, guys, there will be several mango trees out here, right? So what this computer vision agriculture drone will do is, guys, based on this camera, guys, it will able to capture the fruit of a mango. It will try to go to a tree of a mango tree, and it will try to it will try to scan the entire mango tree, and out of that scanning, guys, on the basis of the color, basis of the sensory organ, sensory touch, or kind of a texture, you can say, not actually. So let's try to understand this way. Based on the color pattern, okay, based on the color pattern, and based on the, guys, texture, you can understand the texture of this entire mango fruit. Okay, this mango fruit and the color of the mango fruit, guys, it will able to bifurcate which is the ripened mango and which is the raw mango, and which is the ripened mango, which is the raw mango, guys, and it will be able to pluck out, it will be able to pick out the ripened mango out of the fruit without harming any tree, and it will try to put it in the basket. It will try to put it in basket. It will try to perform the packaging, and it will be ready for the shipment, guys. So that kind of a drone they have created here, that kind of a machine robot they have created, guys, and it is based on the computer vision. Based on the computer vision, that means the entire machine or the entire robot algorithm is able to see the thing. It is able to bifurcate that mango fruit on the basis of the color and basis of the texture of the mango. You guys can understand, right? The mango, when it is ripened, the texture of the fruit is different. And the one, let's try to understand the skin of the mango. If the mango is ripened, the skin will be smooth, right? Very soft skin will be there. And if it is a raw mango, obviously it will be hard skin and the color will be different, right? So mostly the color, the mango which are ripen are in the yellowish in the color, orange in the color, or the combination of yellow, orange, and kind of a green color will be there, right? But here the raw mango will be completely green, right? So if I try to train my model, if I try to train my algorithm, and it will be able to understand which one is the ripened mango, which one is the not ripened mango, and that algorithm I'll try to fit it with the camera in my bot, how kind of a drone, and that drone will go to your tree. It will try to pluck out the mangoes which are ready for the shipment, and to try to put it in the basket. It will try to package them, and it will be ready for the market. That kind of advancement is now reality which is happening out here, and that is one more example where the computer vision is working. As how it is working, based on the computer vision technology, right? So it is able to understand what is happening, and it is able to see through the computer eye, and it is able to perform the human like task, right? Human like task. Otherwise, you guys know, in the farms, when we try to hire the kind of a laborers, it is very costly nowadays. We are not able to get the laborers. And let's imagine that there is a prediction given. So how this will help, guys? What this computer vision will help us? So let's imagine there is a prediction that there's going to be a prediction of the rain, and you know, guys, that within the 2 or 3 days it's going to be raining out, and you have a mango farm out here. So in the mango farm, if you cannot employ all the laborers, because it will be very costly, and pluck out if your mangoes ready to be shipped, then you can deploy the drones. They can be able to pick out all the mangoes which are ready for the usage, and it will be able to ship out them also, right? So this kind of advancement, and that to very low cost. If you try to make that manufacturing in India, And if you try to develop that kind of model, this is one more use case, guys, for agriculture. So that will be very helpful. At the low cost, we'll have a high-end technology available, and which will be less costly than the even actual farmers, labors, right? So that kind of a things, guys, and this is called as computer vision. Let's try to understand this in detail, how this computer vision can help and what kind of a use cases are there available in the computer vision, right? So guys, before we try to understand this computer vision technique and we try to dive into the entire CNN, I will give you a short demo, like 5 minutes demo. What we're going to do is we're going back to the biology class. I know now it's a time that we have only 5 minutes, but 5 minutes are more than sufficient, guys. We'll try to understand actually how the computer vision works upon. What is computer vision, guys? Computer vision is the eye of a computer, we can say, and it is able to perform the task using which the entire human beings are able to perform a visual recognition task, right? So the same task or some kind of a things by use, we can understand the videos, we can understand the images, and we can bifurcate, we can track, or we can perform the prediction, guys. All right. So that kind of a task are coming into the computer vision, and this entire computer vision technique, if you want to understand what is this computer vision and how the convolution neural networks are performing, you need to compare that thing with our biological computer vision technique, guys. So for the moment, let's try to understand. Just give me 5 minutes, and within the 5 minutes, I will be able to take you to a biology class. In the biology, we'll go back to our 10th and 12th class, and we'll be able to understand how the computer vision techniques works upon. And in order to compare the computer vision technique, guys, we need to understand something called as human vision technique. Okay. So in 5 minutes, guys, I am sure it is a 5 minutes are remaining. I can understand. So 5 minutes are more than enough for us. Try to understand this one, and we'll try to compare, and we'll try to conclude our session then, and we'll try to continue our discussion further, deep dive into the computer vision. So guys, in order to understand the computer vision, we need to understand the human vision first. How the human vision works upon, very, very interesting topic, guys. And once we understand the human vision biologically, then we can understand, since this AI is a copy of the human being, so it is we trying to imitate the neural system, biological neural system. Same way in computer vision also is a neural system are being copied, but this time they are not copied the simple functionality, they have copied the entire human vision. They are copied the entire human vision functionality, guys, and that human vision functionality is called as computer vision now. It is exact copy of the human vision, that is called as computer vision now. Computer vision, or you can say that is created using the convolution neural network. All right. So guys, let's try to understand. Let's try to focus for 5 minutes how the entire human vision techniques works upon the moment we are able to see our pictures, videos, any object, how the recognition happens in the mind, how the brain works, how the entire human brain works, how what are the layers present, and through which the processing happens, and how we are able to recognize all the vision related tasks. Okay, we'll try to understand this in 2 to 5 minutes, guys, and then we'll try to compare that tomorrow with the computer vision and try to understand the convolution neural network. All right. So guys, let's try to understand. So let's imagine I am passing one kind of a picture here, so everyone can understand this is the fruit basket. Within that there is a basket, and within that there are various fruits available. Okay. So if I try to pass this picture to the human vision, guys, what is happening? This is eye, right? This is eye, and through eye, guys, this picture will get captured, right? So the eye is our camera now. For computer, there will be camera, obviously, and that camera will be able to capture the image. For us, human vision, it is the eye. Through eye, we will be able to capture any image. We will be able to take the image. Okay. So once the image is taken, guys, once the image is taken, what is going to happen? Let's try to understand. So once the image is taken, guys, this is your brain. Okay. So this is the picture of the brain. Now let's try to understand. I'm going to divide this brain, guys. We'll try to understand by use. We will try to understand how the human vision works upon, and what are the human vision techniques are there. What is the layers are available. So this human brain, guys, this human brain has a 4 compartments actually. This human brain has a 4 compartment. Compartment number 1, compartment number 2, compartment number 3, and this is our compartment number 4 in the back of your brain. Okay, in the back of the brain. Yes, Nisha, I will try to share the link with everyone once again. So I am sharing it in the comment chat box. It is already shared by the Chandana as well. It is the same link I have already shared with everyone. Okay, so guys, let's try to focus for 5 minutes, and I will try to conclude. Actually try to understand, which is very, very important, guys. If you want to understand the computer vision, let's try to understand the computer vision, human vision first. So what is happening is, guys, in our brain, this is the picture of our brain, human brain. Okay, in the human brain, guys, human brain is divided into the 4 parts actually. 4 parts. Well, this is part number 1. This is part number 1. This is part number 2, guys. This is part number 3, and this is part number 4 at the back of the brain. At the back of the brain, there is a part number 4, and this part number 4 is called as cerebral cortex, guys. Cerebral cortex. Cerebral cortex. Okay. Cortex. Now you'll start laughing that why this Vikas is telling us this biological term, right? So you must be laughing that why he's teaching us biology. This is computer vision class. So guys, first try to understand the human vision. and then we can compare, then we can understand the computer vision. Okay, it's the same copy. So if you understand the human vision, so then only you will be able to understand the computer vision, guys. So there is something called as cerebral cortex, guys. If you try to go to Wikipedia and you try to search about the how human vision works, you will try to understand the same thing, that human brain is divided into the 4 compartments. The fourth compartment is called as cerebral cortex, and this cerebral cortex is responsible for the all the vision related tasks, guys. All the visual recognition related tasks. Okay, all the visual recognition tasks are done by this 4th compartment, that is called as cerebral guys, cerebral cortex. CORTX, cerebral cortex, visual recognition. All the visual recognition related decisions are taken by this 4th part of the brain, guys, and then based on the signals fired, the human is able to take the action, guys. Even human is able to understand the people. They can bifurcate the people. They can understand as Vikas. They can understand Sanam as Sanam. They can understand the Nisha as Nisha. Okay, so this is what it will be able to understand. It will be able to understand which is human, which is tree, which is object, which is non-living object. It is able to bifurcate, guys. This is something called a cerebral cortex. Now, what is going to happen? Let's try to understand within the 2 minutes, guys. What is going to happen? Let me now. Everyone is clear that whenever we try to take the picture, that picture will be seen through the eye, and it will be passed on to the human brain. In the human brain, guys, there are 4 compartments. Within the 4 compartments, and within that, the 4th compartment, which is present in the back of the brain, guys. Back of the brain, if you try to understand, there is a cerebral cortex, and this cerebral cortex is responsible for visual recognition, guys. All right. So let me rub these things and let's try to understand this cerebral cortex. Guys, this cerebral cortex has the layers, different layers. Layer number 1, layer number 2, layer number 3, and similarly for layer 3, there will be layer 4 and layer 5, guys. Visual layer 1, visual layer 2, visual layer 3, and visual layer 4 and 5 will be simultaneously available with the 3 and 4, guys. And when we try to pass an image, let's imagine this image we are passing, this image will go to the cerebral cortex. And from the cerebral cortex, guys, there are 4 layers present. Vision layer 1, vision layer 2, vision layer 3, vision layer 4. And from that layer, entire processing will happen, guys. And what is going to happen, guys? Whatever information we have passed, whatever image will pass, it will go through the layer number 1, visual layer number 1. Visual number 1, guys, is responsible for the outer shape. Okay. It is responsible for the outer shape. Means what is going to happen, guys? Let's try to understand. So it is not that we will be able to understand the entire picture as it is at a one glance. No, what is going to happen is it is going to pass through the different layer number 1, 2, 3, 4, 5, and then the entire image is going to appear in the mind, and they are able to understand what the image is all about. So first time, what is going to happen is outer layer or outer shape, guys. The outer shape means this shape, outer shape, basket shape, and this basket is available, and the fruit outer shape is there. This outer shape is recognized at layer number 1. Layer number is responsible for outer shape, guys. Then layer number 2, guys. Layer number will try to focus one step ahead. It will try to focus what kind of colors are available. What kind of patterns are available. What kind of patterns are available. And within that, guys, in the third layer, it will be able to detect the edges. It will be able to detect the shapes, guys. Able to detect the edges and shapes means this kind of edges, circles, small circles, fruits available. Yeah, guys. Hands-on session actually not possible to create entire hands-on session simultaneously, but I'll try to give you code implementation so you can practice at home. Okay. So, guys, let's try to understand in 2 minutes what is happening. So, when you pass the image, guys, it will go through the cerebral cortex, 4th part. This is available here in the back of the brain, cerebral cortex, CB, and 3 CB has the layer, guys. Layer number 1, 2, 3, 4. First layer will try to take the outer shape, guys. Then second layer will try to take the color and patterns, and the third layer will try to understand what is present inside the small pattern edges, and then it will try to understand the texture, guys. And then in the layer 3 and 5, when we try to combine the information, the entire picture or the entire shape will appear, guys. This is how the entire computer vision will try to understand. Once the shape available, guys, then it will try to classify that shape, or it will try to recognize that shape. Okay, this is how the entire computer vision works upon, guys. And based on this layer by layer processing, layer 1, layer 2, layer 3, layer 4, layer 5 processing, guys, so it will be able to understand or recognize the entire image. Okay, this is how the entire computer vision works out on. Okay, let me rub these things and let me tell you once again. So there is something called as cerebral cortex. Yes, cerebral cortex, and this cerebral cortex will have a layer number 1, layer number 2, layer number 3, and simultaneously there is layer number 5 and layer number 5 guys, and 4, sorry. And this information will first come to layer number 1, then from layer number visual layer number 2, it will come to 2, from there 3, and simultaneously it will go to 4 and 5. So first it will try to understand the outer shape guys, and then it will try to understand the color, the pattern, then color and pattern, then in the layer 2 and layer 3 guys, it will be able to understand the detect the edges and then texture, and then the entire image will get appear guys. All right, so this is what the entire computer vision works upon, layer by layer, and all the information which are available in visual layer 1 will also be shared with the visual layer 3, visual layer 4 and 5 simultaneously, and in the end guys, the entire shape will appear. In the end, entire shape will appear, and then the image recognition, visual recognition will happen guys. Visual recognition will happen. So this is how the human vision works upon guys. So I think everyone is now able to understand successfully that how the human vision works. Tomorrow we'll try to compare once again this entire human vision, and we'll try to understand how the copy is created, which is called as computer vision, and then we'll try to start with the convolution neural network, and we'll try to build one convolution neural network, and use cases we'll try to see guys. All right. So other things we'll try to talk it tomorrow, guys. I know it's late now, so 5 minutes. So I hope now you guys were able to understand successfully today how to build a ANN, what kind of a parameters are there, what kind of a tuning is there, how to use the same thing for the image data and the structured data, and then we have just started the introduction of computer vision, guys. Right? And within that, we are able to understand how the entire process works upon for the computer vision, something called as cerebral cortex. And if you try to go and back and read with the Wikipedia guys, you will try to understand the same thing, same information is available. All right. So guys, I hope you enjoyed today's session as well. I know it is very interesting topic. Going forward, we'll try to understand the latest technologies as well, and hands-on, we'll try to take it more hands-on guys as on possible. So that's it for today guys from my side. Hope you enjoyed the entire session. So please let me know your feedbacks, and please go ahead and ask if you have any questions, any doubt as of now. Yes, I will explain. I will share this link. Yes. Anuja ma'am, it's late today. I am already shared this with my colleagues, and they will upload as well in the LMS. And I will try to share the same link, whatever code we have explained today. Tomorrow in the session, I will try to share the same links. Okay. Don't worry, I'll share all the links tomorrow. Yeah, guys, apart from that, any questions, any doubts? I hope you guys enjoyed today's session, especially about the code walkthrough, how to solve the problem, how to build the neural networks from the scratch. Yeah, guys, please let me know if you have any questions, any doubts, any suggestions as of now. We just started with the computer vision. We'll try to continue tomorrow. We'll try to understand the entire latest models for the computer vision, try to solve the use case also. Image and video tracking, we'll try to do. Detection, video detection, and image detection, person detection. And yes, I'll share all the codes. Don't worry, Anuj and other guys, I'll share the code. Yeah, guys, please let me know for next 2 minutes. Yeah, Aruna ma'am, thank you. Thanks. Hope everyone enjoyed the session as well, guys, today. You found it useful. Everyone was able to understand entire things. Any questions, any doubts? Yeah, thank you, guys. Yeah, thank you. Anything else, guys? Any questions, any doubts, anything else you want to ask? System related queries, guys, you can speak to Chandana. You can write her if you are not able to understand anything. Okay, what can be the research challenge? Yeah, ma'am, Fatima ma'am, I'll speak about it. Nice question, actually. Very helpful. Thank you. Yeah, Amar sir, thank you. Thank you. Thank you, Rupali ma'am. Thanks for your kind words. Feature fusion on images. Yeah, if possible, I'll try to understand this. Superb explanation. Yeah, okay, clear understanding. Santosh sir, thank you. Santosh Meyer sir, thank you. Thank you for your kind words, guys. So just a moment, guys. Just a moment. I'll try to take a screenshot for the same. And apart from that, if you guys want to ask me anything, any other questions, you can go ahead, please, till that time. Anything else, guys, if you want to ask, please go ahead. Yeah, okay. I'm reading here. Ravana Kumar, sir, thank you. Pushpa, how to extract features? Yes, yes, I will explain this, sir, tomorrow. Pushpa, sir, ma'am, I will explain this tomorrow, how to extract the feature. Yes, yes. I'm going to cover all these things, sir. Don't worry, sir, ma'am, I'm going to cover. Pramod, sir, thank you. Thank you, thank you. Pranita, ma'am, thank you. Thanks for your explanation. Thank you for your kind words, guys. Yes, I'm going to cover all the things, how to extract the features, how to perform this entire flattening operation, all the convolution operation, everything. I will try to create our own architecture as well. Don't worry. We'll try to create our own architecture as well, guys. Feedback link. Chandana, can you please share again, once again? Feedback link. Dr. Sadlini Rama Rao is asking for this one. Sadineni Rama Rao, sir, is asking for the same. Can you please share the feedback link once again in the chat box? Promoters saying, are we touching by any chance of AI or application of AI? I would love to do that, but due to the limitation, guys. So actually, if you, sir, actually, if you try to see, these topics are so vast that actually we are supposed to cover convolutions operations today, but because of the topics and because of the entire code walkthrough, we cannot accommodate that in the particular 2 hours time. So otherwise, I would have loved to show you this cyber security kind of a concept as well. Yeah, Fatima, ma'am. Yes, I will share with you. Yes. Yeah, okay. I've done the same thing, Fatima, ma'am. Yes, sir, Fatima, sir, ma'am. Yes, I've done that. Anything else, guys? Anything else you guys want to ask? Chandana has shared, guys, the entire feedback link once again. Okay, thank you, sir. Pramod, sir, thank you for your words. Okay, Rao, sir, thank you. Okay, guys, I think no more questions are coming up then. And Chandana has shared once again, guys, this link for the feedback and the attendance. The link is same, guys. So you can take it and you can mark your attendance and feedback out there. And hope you have enjoyed this session thoroughly. Video recording, Amar sir, yes, it is available. You will get the video recording. Don't worry. Actually, I missed that earlier one. Rupali ma'am, thank you. Everyone is thank you. Nisha, thank you. Recording will be available, guys. Don't worry. Guys, anything else apart from this? Please let me know. Last 1 minute. Otherwise, we will close the session then. All right, guys. I think no more questions. Then we can conclude our session for the day and see you tomorrow then, guys.
Yeah, thank you, Vikas. We'll wind up the session.
Yeah, yes. Please go ahead.
And whoever have any query regarding LMS, drop an email to edl@excello.com. So my team will connect you. Like I'm sharing the mail ID in chat box. Please take from the chat box. Yeah, okay, Vikas will wrap it up today.
Yeah, okay. Thank you, Chandra. Thank you, everyone, once again, and see you tomorrow then. Bye. Good day.
Yeah, bye.